Are we ready? So let's discuss the concept behind circular motion, right? So this is mechanical engineering science. So are we ready, please? So first things first, when it comes to circular motion, check you're in the one, you're already level then. When we're doing static, I explained something to you that when we're coming to my class, I drew a graph for you that time. I said when you have two graphs this way, you have a graph this way, one like this, and the other being like this. And I asked you which one is correct. I said when I have upward force, positive, down is negative, right is what? Positive, left is what there? Negative. Is this correct? Or if I have up as being negative, down as positive, right as positive, left as what there? Negative. Which is correct? Normally, initially, you guys are familiar with this one here from your graph, SS1 graph, SS2, SS3, this concept. You know this one very well, but this one looks more stranger because how can upward become negative and down become positive? I said last time these two are correct. Then there is this split. This one follows what? The concept behind what the static. Static. That you did last class, F1, F2. Yes. That's static. Now, and the two are doing what now? Dynamics. This is dynamics here. Are we good now? So dynamics has to do with what? Motion. So you're in what? Circular motion. So what you are doing now is not what? No more static again, but now what? Dynamic. Things will be moving now. Are we good, please? Not like you're having this one like the F1, F2, those concepts is done now. I don't do that one now. What I'm doing now is what? Dynamics. Please put on, please. Let's start with definition, please. So understood, Abby? If you have any question, feel free to ask, please, and let's get us done. First things first, let's do definition, please. Definition. I can call this man circular motion, also called the rotational motion. Are they the same thing? Yes. Circular motion and what? Rotational motion are the same thing. Put on, please. Circular motion is simply a motion of a body in a circular path. Circular motion is simply what the motion of a what? Of a body in a circular path, please. Circular motion is simply what a motion of what? A body in what? In a what? Circular path. That's all, please. How good? Yes. Circular motion. For circular motion, please. For circular motion, there are three important concepts here. For circular motion, there are three important concepts here. Number one, for circular motion, there are three what there? Important concepts there. First one is called the angular displacement. Angular what there? Displacement. Number two is called angular velocity. Angular velocity. Number three is called the angular acceleration. Angular acceleration. Please, when it comes to circular motion or rotational dynamics or rotational motion, I can call this man circular motion, rotational motion, or what? Rotational dynamics, whichever one you are good to go. Now I'm saying this, please. When it comes to this concept, there are just three things you need to know. What's the first one there? Angular displacement. Number two is what? Angular velocity. Number three is what there? Let's look at this concept one after the other, please. Subheading number one, please. Angular displacement. All right. Angular displacement. I'll go, please. This is the angle. This is the angle. Please open a bracket. This is the angle. Open a bracket. Copy this down, please. In radian. This is the angle in bracket in radian. Close the bracket, please. How good? through which a body rotates. This is the angle in bracket in radian through which a body rotates about a specific axis. About what there? A specific axis in a given direction. In a given direction. I will go please. Full stop. It is represented by theta. By theta. Look up please. Theta, this symbol. I think we're all familiar with this one. Huh? You know this, right? Yeah. It is represented by using the Greek symbol theta. How good? Mathematically, angular displacement is what? Theta, right? Is equal to what there? S over R. Now, what's X? Now, check the thing I gave you. What I say? Angular displacement is, please check. Axis in a given what there? Direction. Now, I'm saying this, please, that theta signifies what there? Angular displacement. And the formula is easy. What formula there? S is distance over what's R there? Radian. Now, listen to this. So, I'm saying this as the formula for angular displacement, where, let me show you, please. Where S signifies, let me give you everything, please. So it's called linear displacement. How good? Or you call it distance if you want to. Distance. If you want to. And that's what? Is in meters, right? Is in meters. Also, R, we said R is what there? The radius of circular path, Abi? Radius of what? Circular path. Am I correct? So also in what? In meters, right? In meters. This one too is measured in what? In meters. Their distance in meters. This one too is in what there? In meters. Finally, theta. What's theta? What's theta? Angular displacement. All right. Displacement. Yes, I will go please. Also in what there? What's the stuff there? Angular displacement. What will be the SI unit? Are you sure? Yes. Okay. Oh. We said check what I gave you from the beginning. Define angular displacement. What is angular displacement? This is the angle. This is the angle what? In radian. So whatever you're having, 5 radian. Are we good now? So the S sign for angular displacement is what? Rad. Radian. Short form is rad. RAD. If my answer is 5, don't start writing 5 radian. It takes time. How good? Just write 5 what? Rad. That's all. So I'm saying that the SI unit for what there? Angular displacement is what? Is radian. What's the short form? Rad. Please. I would please. Example, please. Example. Any question before proceed? Any question before proceed? Any question? Example 1, please. Example 1. Shall we? Should proceed. When it passed, did you show in the camera? Okay, let's proceed. Number 1, please. A man travels around a circular path. A man travels around a circular path that has a diameter. A man travels around a circular path that has a diameter of 40 meters. Sure? Okay. How good, please? Diameter of what? 40 meters. Please don't forget, I'm saying again, that angular displacement is what the distance over what the radian. What's the unit for angular displacement? Rad. Are we good? This man is in meters. Yes, in what too? In meters. Okay. If he runs round the path, if he runs round the path for a distance of 56 meter, if he runs round the path for a distance of 56 meter, what is the angular displacement? That's all. What is the angular displacement? Now, listen and listen. Your first task in science is what? List out what you are given. Help me check, please. From the workings there, what was given there, please? So, given, what are we given there? It says what? So, I'm given the first thing there, diameter of what? 40 meter, Abi? So, first I'm given what? Diameter. Number one, given. Abi? And that's what? D, Abi? What's the value for diameter there? 14 meters. No problem. What next there? What next? What's distance? Number two. Distance, Abi? What's the value for distance? Huh? 56. 56, please. Oh, I didn't say 6. So, meters, please. Oh, not 6, please. Are we good, please? What next there? That's all. We have to find what? And that's what? Theta. Are we good? Please, words, don't cram. It's simple. We have to find theta. What do we know? Recall that what's theta? Theta is what? S over R. This is what we know. Now ask yourself, to get theta, I need two things, Abi. S and R. Is S given? Distance, Abi? No problem. Is R given? No. But what are we given there? Diameter. So you can convert radius to what? Diameter. Yeah. So now, working on radius, please. Recall from your mensuration idea, all those circle concepts, that radius is what? Diameter over 2. This is mathematics. Under circle, you should know this. Now, let's get what the radius will be. So, what's R now? R will be equal to what? What's diameter? 14 over what? 2. So, what's R in this case? 7 what there? 7 meter. I have gotten R now. I know X. I can get what now? Angular what there? Displacement. From here now, theta is equal to what there? X. What's X? 56 over what's R there? 7. What's value here, please? What's value here? 8. Theta is what there? 8 what? What's the unit here? Rad. 8 rad. 8 rad, please. 8 rad. How good, please? Copy down. Let's proceed. 8 rad. Copy down. Let's proceed. Example 2. Before proceed. Before we do the other one, let's do example 2. Can I take this part? Can I take that? Yeah. Is it recording? Yes. All right. Number 2, please. A ball travels a distance of 1,800 cm. A ball travels a distance of 1,800 cm. Full stop, please. Through an angular displacement of 7.2 rad. Through an angular displacement of 7.2 rad. Full stop. I will go, please. Without even me telling you angular displacement of 7.2 rad. If I give you 7.2 rad, what does that mean there? Angular displacement. So sometimes they won't give you the name. Through the unit, you should what? Know what I'm talking about. I will, please. What is the radius of the circular part covered by the ball? What is the radius of the circular part covered by the ball? What is the radius of circular part covered by the ball? Let's list out what we are given, please. It says a boat travel a distance of what? 1,000. Don't say maybe. That distance, that's x abi. So x is given as what? 1,800 what there? cm. Are we good, please? What next? Through a what? Angular displacement of what? So what's given there? Theta abi. Theta is what? 7.2 rad. No problem. It says what is the what? Radius. So we're looking at what? R. R is what? R is what? Unknown. Please, this is simple. If I ask you, what is the relationship between S, theta, and R? What's the relationship? This one here, Abby? Yes. Am I correct? Yes. So we know the relationship already. So let's recall the format that we said theta, which is what? Angular what? Displacement equals what there? S over R. We are asked to look for R in this class, Abby. Make R what? Subject. Just swap. Listen, just swap it. That gives you what? R equals what there? S over theta. That. So just swap it. You have this one here. Please, to get R, we need what? Two things, Abby. Yes. What's X? Just given. No problem. What's theta? Very good. Now listen. Check here. When I gave you the definition for angular displacement, I said S is what? Distance, Abby. In what? In meters. In what year? Convert to what? Listen, that's why I give you all these things. Oh. Yeah. They all have in meters. 180. One what? 180, right? Yes. cm, Abby. Sorry? Meters, Abby. Is this correct? Yes. No. Is this correct? Centimeters to meter, they were 100. Is it 18? Is 18 now? Not 180. Is 18 what? Meters. So if we want cm to meters, it's just 100 meters right there. Are we good now? Any other thing? Theta is what? In radian, right? Is in rad. So it's correct. So let's work in this. What's x here? What's x? 18 over, what's theta there? 7.2. Please, what's r? 2.5 what there? Rad. Very good. So your radius is in rad, Abby? No. Radius is in rad. Is radius in rad? So he told me rad. Because R stands for rad, Abby? You rad in exam, yeah. So we said radius in what? In meters, not in rad. Malo rado. In what? In meters. That's all, please. Are we good, please? Any question, please? Please always convert to meters. Are we good? Important. Number 2, angular velocity, please. Number 2, angular. After this class, I will check the past question in that PDF. By now, after the class, you should be able to solve it yourself. Yes. Are we good now? Yes. Number 2, angular what there? Yes. Velocity, please. Let us call angular velocity. Is it fine? What are you saying? Okay, you're right. Let's see your results. But see, sometimes if you are dull, you don't know book, you know you are not smart, but you have fun writing. You can win, no. You can win, no. See, there's some people that are very, very good, but bad writing, they will lose. So you should balance it. I'm serious, so you should balance it. Number 2, angular what there? Velocity. Definition, please. This is the rate of change of angular displacement. This is the rate of change of angular displacement. This is the what? Rate of change of angular displacement. Full stop, please. It is represented by a Greek symbol called omega. This one here. Omega. By a Greek symbol called omega. A Greek symbol called what there? Called omega. This omega here. Full stop. Mathematically, Mathematically, how good please? Omega, please, before I give you the mathematical form, please listen. Listen. When you hear the word rate of change in any way in life, is a what? The time-bound word. How good now? If I say Abuja displacement, it means what there? Abuja over time. How good now? Canada displacement means what? Sorry. Yes. Sorry, if I say Canada rate of change, sorry, that's what there. Canada what there over time. Abuja rate of change means what there? Abuja over what there over time. Please, who will tell me what's formula for this one here? It says rate of change of angular displacement. What formula here? That's what there. Theta over what? Over time. That's all. No cram. We said for angular displacement, it's just theta abi. That's x over r. This one is what? That angular displacement abi over what there? Over time. That's formula, please. Over what there? Over time. All right. I will go, please. In this case, what is the unit for angular displacement? Rather, abi? What's the unit for time? So what's the sign for omega? That's all, please. So that note that angular velocity is measured in what? Rad per seconds. All right. SI unit is what there? Rad per seconds or rad to power minus 1, abi? So any of it, either this one here or this, whichever one, it's the same thing, please. So I'm saying this. I said for angular displacement, what's the sign in there? Just rad. Moving on, this one gives what there? Rad per second. Moving on, you have what? Rad per second square. That's the last one, right? But we'll get there. So now in this case now, I said angular displacement is not hard. Go back to the having here. That's what your angular what? Displacement over what there? Over time. I will go, please. Now from here, let's try to okay, let me just give you the definition, please. Where omega means what there? Angular, in case you want to read, angular velocity. Of course, what's the unit there? Rad per what there? Seconds. Number 2 there. You know theta now. What's theta? All right. What again? What's t? Time. That's all. Now listen and listen. Please listen. Listen. Now listen. Listen. No. For angular velocity, what's formula? Omega is what? Theta over time, abi? Please. The formula under this one, under these 2 and 3, I will give you. There will be 2 different formulas there. So I have 2 formulas. That third one will have what there? 2 formulas. But angular displacement has what just what? 1. And that was formula there. S over R. That's all for this one. It's gone. Now for this part here, I'll give you what? 2, abi? What's the first one there? This one. Second one now. Note, please, everybody. Note. Note, please. Note this thing, please. Note. Relationship. Note, please. Is it showing? Yeah? You just want to spoil my video. Oh yeah. Just pass. You sure, Abby? No. Alright. Relationship between linear velocity and angular velocity. Relationship between linear velocity and angular velocity is given by the equation angular velocity equal to t over r. I said the relationship between angular velocity and what? Linear what? Is given by the equation on the board, please. Now listen, don't cram. It's easy. When we say angular velocity and linear velocity, from what linear velocity is normal v, your normal v. Am I correct? Normal v is your linear velocity. We know initially, abi. But the word angular what velocity now is not changes. That's what your omega. If they're asking exam, what's the relationship? Omega is what there? V over R. What's R? Radius. In what? In meters, Abi. What's your velocity there? Is in meters per seconds. Ami? Yeah. Meters per seconds, right? This one is what? In meters. How good now? So know that our sine theta over t, they see what there? V over R. Example, please. Example, please. Before we do example, have you noted this? Note number 2. Note number 2, please. I'll proceed. Note number 2. Please. If I say if I hear the word one revolution, what does it mean? 360, Abi? All right. So note, please. Number 2. Note number 2. Number 2. Please note that for one revolution is equal to what there? 2 pi rad. 2 pi radian. Please note that for one complete a revolution, I have what there? A 2 pi rad, which means in short form, 1 rev equals what there? 2 pi rad. Please note this, very important, please. Now listen, here's the technique and the idea. Listen. One revolution means what there? 360, right? Yes. So it is important to know that one, so it means I'm having 2 pi. 2 pi contain what there? A full revolution, Abi. So if I have 1 pi, what 1 pi? If 2 pi, listen. 1 rev gave what? 2 pi, Abi. So it means that 1 rev has what there? 360 degree. If I have 1 pi, what does 1 pi signifies? 180. Am I correct? So if I have 1 pi signify what there? 180 degrees. True. And 2 pi signify what there? Your 360, which is what there? 1 revolution. Are we good? You said 2 pi is 1 revolution. And 1 revolution is what? 360. So 1 pi gives what there? 180. Half. 2 gives what there? 360 degrees. Are we good, please? So important to note this relationship between 1 revolution and all these concepts. How good? Before we do example, let's do number 3 and then combine them together. Number 3, angular what there? Angular acceleration. Number 3, angular acceleration. Angular acceleration. Definition, please. Definition. Please go and learn definition. Oh, they ask to define. Oh, this is the rate of change of angular velocity without telling you. What's the formula? Listen, I said this is the rate of change of angular velocity. That's all. So see, don't cram. Oh, the beginning was S over R. Next up, theta over T. Next up, omega over T. Don't cram. All right. I said what there? This is what? This is rate of change. This is the rate of change of what? Angular velocity. Abi, full stop. It is represented by a Greek symbol called alpha. Alpha. Abi. It's represented by a Greek symbol called alpha. Please, alpha is for angular what there? Listen. Theta is for what? What's it called there? Omega is for what? What of alpha? No them. Please now listen. Let me know who is brilliant here. Listen. When I said for this one, I'll give you 2 formula, Abi. This and this, Abi. This one I'll give. How many here? 2. I'll give you 2, Abi. Now, if I give you the 2, what's the first one I'll give you? We said this one is what? Is what? The rate of change of what? Angular what there? This one, Abi. That gives you what? Alpha mathematically. So what's alpha there? Alpha is what? Omega over what there? Over t. Angular what? Velocity over what? Over time. Don't cram. All right. Omega over perhaps over t. I have this place. Now, if this one here is omega over t, now listen and listen, please. So what's the sign? What's the sign here? What's the sign here? That's all. Rad per what? Second square. S sign, please. S sign unit, please. So the S sign of this man here, we said alpha is what? Omega. What's omega S sign unit there? Rad per second. That gives you, look up please. Rad per second, Abi. Now divided by what's t? Seconds, Abi. So seconds. Now let's work on this, please. This gives you rad per seconds. Change this to what? Times, Abi. There's an invisible one here, Abi. Put this one up first, Abi. Comes down here, Abi. So rad times 1 gives you what there? Rad. S times gives what there? X squared. This is what? Rad per seconds. I will go please. This is the S sign for what? For your alpha. So know that the S sign unit for what's it called? Angular acceleration is what? Rad per what? Second square. Please. Very important. So it's easy. First one was rad. Second was the rad per second. And what there? Rad per second square. So this is how you work with this. Now listen. Now check this out, please. Don't cram. Just check this. Understand it. Number 2, I gave you angular what there? Velocity, Abi. We said that there's a relationship between them. That omega is what? Over what? We said angular velocity is what? Linear velocity over what? Over r, Abi. What will this one become? Angular acceleration is equal to what there? Linear acceleration over what there? Over r. Do you get? The one I gave you for number 2 was omega equals what there? Linear over r. So because of there, angular what? Acceleration is what? Linear acceleration over what? Over r. Are we good now? So I'm saying that note, please. Note. From here, note. From here, note. The relationship between, note please. The relationship between angular acceleration and linear acceleration, from here please, note. The relationship between angular acceleration and what there? And linear acceleration is given by the equation alpha equals a over r. All right. Alpha equals a over r. Alpha equals what there? Please, I will go, please. Any confusion? Huh? In summary, we'll start passing now. Pass some full now. In summary, before we proceed, in summary, we said note the following. Theta is what? Theta is what? The name. What's theta? What's alpha? What's omega? What's a? Linear what? What's v? What's r? Please, I'll come up with this. Now, which parameter has the S sign as rad? Which parameter has its S sign as rad? Angular what? Displacement. Oh. If I had rad per second, which parameter is this? If I have rad per second square, that's what these are what you need. Know them when you see them. Pass to number 1, please. Number 1. Number 1, please. Number 1. Number 1. Are we good? If a wheel, 1.2 meter in diameter, if a wheel, 1.2 meter in diameter, 1.2 meter in diameter, rotates at 1 revolution, sorry, per second. Yeah, 1 what? Per second. Are we good? Calculate the velocity of the wheel. Calculate the velocity of what? Of the wheel. Are we good? Option A, 3.6 meter per second. Option A is what? 3.6 meter per second. Number 2. Option B, 3.8 meter per second. 3.8 what there? Option C, 4.0 meter per second. 4.0 meter per second. And option D, 4.5 meter per second, please. Option D is what? 4. What? Are we good, please? Now listen and listen, please. Listen and listen. It's simple. What are we given? First task. What are we given, please? Your task is simple. What am I cleaning? Anyway, Abby? Yes. Well done, Abby. Take this off. Now, your ability to start failing is when you don't read the question and get what they're saying. What are we looking for in that question? What symbol? What symbol? Wait, what are we looking for? Is it angular velocity or linear velocity? What symbol? All right. Now, give us, please. Help me check, please. Given, what are we given, please? Check. Excuse me, I'm going to repeat this thing. I want to feed this so it can be bold, more bold. Are we ready? Are we ready? Please, what are we given, please? Check. What are we given, please? Check. Check. What are we given, please? What's the first thing? All right. What's D? This what? 1.2 meter. What next there? What's given? What next? Huh? One what? Now listen. If I'm having, I'm coming, please. Diameter. One revolution, Abi. That one revolution. Wonder what will it be? Huh? Radian, Abi. That's R, Abi. So what's R there? What's R? Please, what's R, please? One what there? Per what? No problem. What next again? That's all, Abi. Find what there? Find what? The velocity. Not what? Angular is what? V. That's all. Are we good, please? Now, listen and listen, please. For this one here. Sorry, you. Is how listen that I'll give you now? Yes, it's not R now. It's what? Omega. Am I correct? Because this is R per seconds. Look up, please. That you know. Please look up. If I use R, what symbol for R? R is the meter now, and I'm seeing rev per seconds. So what thing signifies something over seconds? That word there was omega. Am I correct? So with SI unit, you can guess what they're talking about, a parameter. From here, can you help me sense out what relates this and V together? And what? Angular velocity, Abi. So recall that we established that we know that omega is of course theta over what? Over t. But we can't use this here. So use what? Omega equals what there? Linear what? Over what? R. Are we good now? Diameter is given already. I can get R. True? Yes, I showed you earlier. That's R over what? R equal to what there? D over 2. Now from here, so I'm looking for what now? V, Abi? Do we know omega? Yes. Do we know R? No. Let's get for R. Calculating for what? Radius, Abi? That's R. So what's R then? R is what? D over 2. What's D? 1.2 over 2. What's my answer there? 0.6 what? Meters. That's R. Now listen, your omega was not supposed to be in revolution, Abi, is what? Rad per second. So that gives you 1 rev is what? 2 pi what? Rad, Abi? Yes. Then what? Per what? Per second. This works. Convert it. Rev. And then I show you that you should note that stuff. 1 rev is what there? 2 pi rad. So normally rad per second signifies what there? Omega. Makes sense now. Can we go now? Now, omega is known, R is known. We cannot get what? We can get V. To get V, multiply this to Abi. So we are saying that V equals what there? Omega dot what? R. This gives what's omega? 2 pi. Am I correct? Dot what's R? 0. What there? 6 Abi. This gives you 2 into 32 over what? 7 Abi. Then into what there? 0.6. So what's V from here? Punch us, please. What's V? Give me all the answers straight up. Straight up. What do you have there? 3.76 meter per second. Please let me confirm. Huh? Which part there? Yeah, Abi. So you know, I'm coming, please. No, I asked to find V. What's to find V? So for me, make me subject. I'll have this, Abi. Now, what's omega? Omega was this initially, Abi. No, I gave you that 1 rev is what? Check a book. 1 rev is what? 2 pi rad. Just take this as this. That's all. Repeat this per second. That's all. What you just need there is 2 pi. That's all. Now, V, Ulangwa, sorry to use. That we're looking for, Abi. So, what's omega? That's 2 pi. Dot, what's your R? R is what? 0.6. Put in value here. 2 is this. Pi is a constant thing in mathematics. And that's what there? 20 over 7. By this. Multiply 2 by this over 7. That will give you this. Yes. Am I correct? Yes. That's all. So we said there is 2 pi rad. 2 pi rad, yeah? That is supposed to be 2 times 20 over 7 and 0.6. And now, this 2 times what? 20 over 7 times what? Oh, no, no. Rad is a symbol. It's the SI unit. It doesn't have to do it. When I gave you, okay, look up. What's angular displacement? Theta, Abi, is what? S over what? R. And I said theta is in what? Is in radian. That's the what? SI unit. Are we good now? So rad, it doesn't have any value. It's just a SI unit. Are we good now? It is revolution. Revolution that has what? A value. And that's what the 2 pi. And now, and I get 1 revolution. That's what the 18360 now. 1 revolution, it moves around the circle, full circle. And that full circle is what? 360 now. And that's what the a 2 pi. If they said half revolution, that's what the 1 pi, 180. No, I have to express them because my angle omega is not in angle. It is in what? Rad. No, they always give me in rad. In rad, to be in rad. I'll go down. Shall I proceed? Now, okay, any question? Any question? Number 2. 2 pi. All right, number 2, please. Number 2. I'll do number 2 for you. I'll give you the last one as assignment for classwork here. You do it here for me. I'll go now. Number 2, please. If an object, okay, you put it down. Is my video clear? Please on camera. Is it clear? Is it clear?
Yeah.
It's clear, Abby? Not really, but it's clear. A little bit. Okay. Bob is not good. All right. Which one am I clean? Everybody? Where? Yeah, Abby? We have done trigo last class. Those that have missed our 3 class. I won't come back. Oh. Go to YouTube, go and learn YouTube. Oh. I've done trig. We're not starting from the beginning again. Oh. If an object whose mass is 3 kilograms, if an object whose mass is what there? 3 kilograms moves in a diameter, moves in a circular path, moves in what there? In a circular path of radius 0.7 meters. Of what there? Radius what? 0.7 what there? Meters. Are we good, please? Records a speed of 2 meters per second. Records a speed of what there? 2 meters per second. Are we good, please? What is the result of the angular velocity? What is the word there of the angular velocity, please? Full stop. Now, there's something strange about this question. What's strange there? Because what? 3 kilogram problem. Because since so far, we're not talking about mass here. But let's see what work out. They give us mass, Abi. So what's the mass there? 3 what there? Mass is of course 3 kilogram. Will this be important in this question? We don't know yet. Continue. What's next there? What next?
Radius.
What's radius there? 0.7 meters. What next? What's radius?
7.7.
No, it's 0.7. Please. Please, oh.
Speed.
What's what speed?
Distance.
Hold on. What did I give you? Read it. This what? This what? A speed. I didn't say distance. Abi?
Yes.
You mentioned distance for me now, Abi. You want to use mathematical for me?
Yes.
It was speed that was mentioned, Abi. Now, listen. Speed and distance are the same thing. I'm asking you. Listen, no. Speed and distance are the same thing. Distance is a space between what? Abi? Speed. They're different now. No, and I'm saying this, please. Note that at this level, you should know that velocity and speed are used what? Interchangeably. Yes, speed. Same thing as what? Velocity. It's just that speed is what? Scalar. Velocity is what? Vector. Now, listen, let me show you this before I proceed. Let me explain this for you now, and that's all. If I have speed and I have the what? Velocity. Please, these two are the same. Yes, they are the same. And still yet, they are not the same. Velocity is what? Meter per second. Speed is what? Meter per second. They are the same SI units, no problem. But in real life, they are different. Why? Speed is scalar quantity. V is what? Vector quantity. You can even hear the word V, vector. The word X is what? Scalar. That's 1 and 2 cases I've given you. They are the same SI units, different quantity. But now check this out. Let me explain this for you once and for all. If I have a road map this way, I want to explain speed and velocity for you. Person A, person B, person C. Now, let's explain speed. I will go now. If person A, young man, wake him up, please. Shall we please? Now, if person A go to person B, listen, oh, this part is important, please. If person A go to person B and ask person B how far, please, where is person C? Person B said person C is 50 kilometers from here. A will confuse. 50 kilometers from where? What am I passing? Is it north, west, or south? He doesn't know, but he knows what the value, but doesn't know what where it's going. That's what speed for you. That's speed. But velocity. Now this is velocity. Person A to person B. How far person B? What's person C? B will now say, okay, oh, C is 50 kilometers northwards or south. So he give you this and what and the direction. That's velocity for you. So at this level, we should know the difference between the two of them very well. They are used interchangeably in science. You can anywhere you hear speed, choose as what velocity. They use it together because they have what there the same SI unit. Scalar vector. Vector means what? Magnitude and what? And direction. This one means what there? Just what there? Magnitude. Are we good? So they said speed of what? 2 what there? So that's V, Abi. 2 meters per what there? Per second. No problem. Now, please, what problem will I use here? Who can tell me, please? Find what? Find what, please? Find what? Omega, Abi. Please, who is clever? What am I using here? That's all. Omega is what there? V over what? R. That's all. You don't need mass. Mass will convince you. Sometimes in science, they'll give what you don't need. So no start mass. No, you don't need it. You already know this two. This two look and give you omega. Why stress? So what do you have here? What's V? 2 over what's R there? 0. What there? 7. What do you have as answer? Omega is what there? What's omega? Huh? Don't use your brain, please. Use your calculator. 2 point what there? 2 point what? 8 Abi? Or 2.9? Alright, 2.9. Please, what's the unit? Omega. Is it rad per second square, rad per seconds? At this level is what? Rad per seconds. Rad per seconds. How good, please? Assignment, please. Copy down. Copy down. For you people, is classwork. For those who watching me online, is assignment, please. And leave your answer in the comment section of this video, so I'll reply you. Don't laugh now. Don't laugh. An object moves in a circular path. An object moves in a circular path of radius 0.5 meter. An object moves what there? Circular path of what? Of radius what? 0.5 meter, Abi? With a speed of 1 meter per second. With what there? A speed of what there? 1 meter per second. What is the angular velocity? Full stop. What is the angular velocity? Full stop, please. For those watching me live, you people here, classwork, online, assignment. So leave your answer to this video in the comment section. So I'll reply you if you are wrong or correct. So see you guys in our next tutorial class. Clap for me now. Clap for me. Okay, thank you.
Before we continue with this lesson, I'm excited to announce that I just launched my official website, a complete learning platform designed to help you study smarter, learn faster, and access high-quality educational resources anytime you need them. On the website, you'll find several well-structured courses created to guide you step by step through the most important topics. First, we have Organic Chemistry for Beginners, a simple, beginner-friendly course that breaks down organic chemistry into easy explanations anyone can understand. Next, there are WAEC and JAMB classes, specially designed to help you pass your exams with confidence using clear lessons, solve questions, and exam strategies. We also have the physics tutorial for Year 1 students, covering foundational concepts you must master in your first year of higher education. And for anyone who wants to grow online, there is a complete course on how to start, grow, and earn on YouTube using only your smartphone. This course gives you everything you need to begin your YouTube journey without expensive equipment. There is also a book section on the website where you can get all my educational books, including the shortcut to academic success. My website is now your one-stop platform for science tutorials, exam preparation, YouTube training, and learning resources that can transform your academic and digital journey. To explore all the courses and get your copy of the books, simply click the website link in the video description. Before we continue this lesson, I want to share something that will make your learning experience even better. I now have exclusive channel memberships designed to help you learn faster, get direct support, and access premium content you won't find in my regular videos. The first level is the support membership. If you enjoy my lessons and want to support the channel while getting special perks, this is for you. It's a simple way to show appreciation and help me continue creating high-quality educational content. The second level is the WAEC and JAMB classes membership. If you're preparing for WAEC or JAMB, this membership gives you structured lessons, practice questions, exam strategies, and step-by-step guidance to boost your performance. The third level is the 100-level students membership. This is perfect for secondary school students who want organized, easy-to-understand lessons in physics, chemistry, mathematics, and other subjects. And finally, we have the YouTube Mastery membership. If you want to learn how to grow on YouTube, how to create content, edit videos, design thumbnails, and monetize your channel, this membership will guide you from beginner to creator. Whatever stage you are in, there's a membership designed to help you learn smarter, improve faster, and stay ahead. To join, simply click the membership link in the video description. Choose the level that matches your goals and start enjoying all the exclusive benefits. Before we continue, let me quickly share something that can change your entire online journey. I just launched a complete YouTube Mastery course, a step-by-step training designed to help beginners start and grow a successful YouTube channel using only their smartphone. In this course, I break everything down in simple, practical lessons. No expensive camera, no studio, no complicated equipment, just your phone and the right knowledge. You will learn how to create quality videos, design engaging thumbnails, write perfect titles, choose the right niche, understand the YouTube algorithm, and grow your channel from zero, even if you've never created a video before. If you want to become an online teacher like me, this course will guide you on how to teach online, record lessons, explain concepts clearly, and attract the right audience. And if you want to create content in any other field, lifestyle, motivation, entertainment, business, this course will still show you the exact steps to succeed. All the lessons are pre-recorded, well-organized, and easy to follow. You can watch them at your own pace, anytime, anywhere. So, if you've been dreaming of starting a YouTube channel but didn't know how to begin, this is your opportunity. This course will take you from beginner to confident creator. The link to get the YouTube Mastery course is right there in the video description. Click it and start your YouTube journey today. Hold on, before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of the shortcut to academic success today. Your future self will thank you.